Hello, this is me going over your first video, which is on the last section of chapter 3, Inequalities. So we've gone over inequalities a little bit before, so we're kind of going back and looking at inequalities one more time because we're going to be solving some inequalities using some of the properties in methods that we've been looking at lately that are a little bit more challenging. So just as a little bit of review, inequality symbols look like, let me see if I can, oops, I think I had that going the whole time. I had to get a marker here. Go over the symbols. For instance, we have this symbol, which is the greater than symbol. We have this symbol, which is the less than, greater than or equal to, or less than or equal to. And I always read these from left to right. And one thing that makes it easier sometimes for this less than symbol is that it almost looks like an L, and an L can stand for less. So I'm going to go over one of these with you, and then I have 2 examples for you to try on your own, and then see how you did. So here is the first example. And so we're solving this inequality. And so sometimes what I do is I just do this line, so I know that everything I have to do on one side of the line has to happen on the other. Also remember with inequalities, if you divide or multiply both sides by a negative number, you have to flip the symbol. So that still applies. So looking at this one here, before we can figure out what x is going to be able to be, we have to be able to get rid of these parentheses using the distributive property. So I'm going to distribute my 3 on the left-hand side, and I'm going to distribute my 5 on the right-hand side. So on the left I have 3x minus 12, and on the right I have 5x minus 10, and then I also have this minus 8. So I could simplify this side a little bit more by combining the 2 like terms. So I'm just going to rewrite this, and I apologize again for how bad my finger handwriting is. There we go. Okay, so I'm doing everything that I would do if I was solving for x in an equation. I just have to remember that if I multiply or divide both sides by a negative, that I have to flip the symbol. So from this point on, there's 4 possible steps you can take, and all of them are probably correct. But I'm going to choose to subtract 3x from both sides. This up here is a 5, even though it doesn't look like it. Negative 12 is on the left. And then I have 2x minus 18 on the right. If I add 18 to both sides, that gives me 6 and 2x. And the last step would be to divide both sides by 2. And that will give me 3. And then this, and then x. You can write it this way, or you can write it so that the x is first. If you do that, it's great as long as you make sure that that symbol is opening up to 3, just like it is down here. So either one of these answers would be good. That means that if we put a number in here that is less than 3, this will be a true inequality. So what I'm going to do is I'm going to give you another example. I've actually 2 examples for you to try. Here is the first one. Okay, so take a minute and pause the video and try this on your own, and then as soon as you're ready for me to go over it with you, then unpause and I will go over it. Okay, so you're back. The first thing I'm going to have you do is make sure that you get rid of the parentheses by distributing the 2. So I have 5 minus x is less than 2x minus 6 plus 5. I'm going to take these 2 terms and put them together because they're like terms. So that's what I have. Now I'm going to add x to both sides. I just want to move my x's to one side and my number to another. So 5 is less than 3x minus 1. I'm going to add 1 to both sides. So I have 6 is less than 3x. And then I'm going to divide both sides by 3. And that will give me 2 is less than x, or x is greater than 2. You can write it either way as long as that inequality symbol is open to the right, x in this case. Okay, got another one for you to try, a little more challenging one. So here is the next one. Okay, so take a minute. This one is challenging, but I think you can do it. And as soon as you're ready for me to go over it, come on back. Okay, so here we have a situation where one of our terms is a fraction. And so if I want to get rid of that fraction, I can multiply every single term by the denominator. In this case, that denominator is 2. So if I multiply each of these terms by 2, I can rewrite this and make it much easier for me to do, because it would make it so that I could cancel out the 2 that's on the bottom of the fraction of the first term on the left-hand side. And so I would have x plus, and then 1 times 2 is 2, is less than or equal to, and then 3x times 2 is 6x, and 2 times 2 is 4. Okay, so I always look ahead and I try to make sure that wherever I'm moving my x's, I'm making the result be a positive number. So that's why I keep ending up with having the x on the right hand side by, it just happens to be a coincidence, but here we are. Okay, next step would be subtract 4 from both sides. So I have negative 2 is less than or equal to 5x, and the last step is to divide by 5. And that's okay if you have an answer that is a fraction. So my answer for this would be negative 2/5 is less than or equal to x. Or you can write that as x is greater than or equal to negative 2/5. Oh man, my finger is not a good stylus. Okay, so this is 3.15. This is the last chapter, or the last section in chapter 3. And if you have any questions about it, you should post them on Schoology. All right.